I'd like to start with looking a little bit at the computing landscape where we are now. If you think about all those servers running in data centers, let's say AWS, based on public information, there are about 3 million machines running in AWS, which might seem like a lot, but to bring this into perspective, if you think about Raspberry Pis that have been sold in the last year alone, it's 10 times more units. And this is just Raspberry Pis. If you look at all personal computers, PCs, sold in the last week, then it's even 10 times more again. So there are 100 or maybe 1,000 times more personal computers, some are out there running in the world, not being participating, not being connected to the decentralized economy. And the question is, how can we fix that? The second part is how actually we are using all of those computing resources we have out there. Most people are not using their CPU for, are not using all of their CPU they have available. Even if you are a developer, or maybe you're editing videos, you are still using your machine at maybe 50% on average. Similarly, if you think about network connections, if you have a household of 4 people who are browsing or watching Netflix, they are playing games, then typically they need maybe 40 megabytes per second of internet speed, but an average American household has a connection speed of 127 megabytes, based on some data I was able to find. So it means like we are using our internet connections at 30% only, and the remaining 70% is there, waiting to be used for something better. And now the question is, how can we make this work better? How can we put this into work to make the Filecoin economy better, or maybe just the entire world a better place? And that's what we are trying to build. And the project is called Filecoin Station. Our vision is to build a desktop application that anybody can install and run. It can be, especially it should be non-technical people like your parents, your friends. This application will use your idle resources, do some meaningful work, and it will reward you with Filecoin in return. So, perfect. But that's very high level, and if you are thinking, how does it work under the hood, or like, what's the technology? The idea is we want to run untrusted code, meaning anybody can provide code to be executed on stations. Stations are operated by untrusted people. There is no contract saying they have to do what we are telling them, and we want to pay for jobs processed by stations. So this is quite tricky. And we are dreaming big. There are so many use cases you can apply to Filecoin Station. For example, we can enable scientists to run distributed computation using data stored on Filecoin. This is a little bit similar to SETI at home or folding at home projects, but with the benefit that you will be actually paid for contributing your resources. We can even pay people sharing content, for example, Saturn L2 nodes, for providing network connectivity and the content to L1 nodes. Oops. We can maybe periodically check for uptimes of all the different nodes which are forming your peer-to-peer network. We can even check that the nodes are actually behaving honestly, that they are doing the work they promised to do. And finally, we can use a fleet of Filecoin stations to measure performance of your decentralized network. And what's very interesting here, you will be doing the measurements from real-world home networks all around the world, which is much better than running some simulated benchmark somewhere in the cloud using simulated network conditions. So there are plenty of opportunities here. Now, there are also many technical challenges which are in front of us that we are actively working on right now. The first one is, if we want to run untrusted code on users' computers, we need to ensure the code is isolated, that the code cannot exploit any resources or maybe access secret data on users' computer. And so that's the first part to solve. The second part is making sure that even if there is a security vulnerability discovered in our isolation mechanism, we need to fix it quickly so that it's not exploited because we were waiting for too long. We also need to limit resource usage, because if the station starts using all your computer resources, spinning your fan, eating all the CPU, and then saturating your network bandwidth, then people will just shut it down and never start it again because they want to use their computers for something else, not only for the station. So we need to find a way how to limit everything that's running inside station to keep it kind of not noticeable by a regular user. And we also need to figure out how much is still acceptable. Like, should we keep the CPU usage just before the fan starts spinning? Or maybe it's okay that the fan is spinning because you are used to it and we just need to not use more than 80%. That's questions we are asking ourselves and discussing in our team. And then a hairy problem once we get to payments is how can the station prove that it performed the job it was asked to do? And I'm intentionally not using not using proof of a work, because in station, it doesn't have to be a work. For example, with Saturn, we want to verify that the station served some content to the L1 node to accelerate content retrieval, and this is not a work. It's more a proof of data retrieval, maybe. So how can we implement this? To make sure that we trust the stations enough that we can pay them. And then payments, right? How can we handle payments in a distributed way? I think, or I'm sure many of these questions have been already solved by Filecoin, maybe Bitcoin, maybe Ethereum, but it's something we need to solve for the station as well, and maybe we can get inspiration from those other projects. And then another challenge is there are too many of them. How do we do job scheduling in a distributed way? If you think about having 1 billion stations running all over the world and you want to run your single job, then how do you decide which station the job should be deployed to? And then if I'm running the station, how can I choose the jobs to run so that I can maximize my earnings? So if I'm on a slow network connection, maybe I should prefer CPU-intensive jobs, and similarly for the other conditions. And then finally, or almost finally, legal issues. For example, with Saturn, if I'm caching content to accelerate retrieval, what if my computer ends up caching illegal content? And then police comes knocking on my door, hey, Miroslav, why are you sharing this video? That's not legal in our country. Who is responsible? Is it me, because I'm running the station? Is it Protocol Labs, because they built the station? Is it maybe the Saturn team, because they are operating Saturn? Or maybe it's all fine, because I'm kind of just being like an ISP, just giving people connectivity. So many questions to explore and answer. And then once we address all of this, we can build a decentralized marketplace, which will allow anybody to submit any job, any computation, or maybe build a cache node and pay for that to happen. And people will be able to earn more money and contribute in more different ways. That's like the final game where we want to get. What is the status? We are currently running an alpha version. You can download it from our website. It's an alpha version, right? So we have a Saturn module, the L2 cache, which is connected to testnet. It's already handling real requests. We have synthetic traffic to test all technical parts. So if you're on the station now, you will see you are handling some jobs, and you are helping us to calibrate Saturn network. There are no Filecoin earnings yet. That's waiting for the official launch of L2. And our main focus right now is to iterate on the UX to make sure the station is easy to use for an average user. And we are also researching more ideas, what kind of modules would make sense to build and run as part of the station so that we can make station a better deployment target. Next, we are aiming to do a beta release, which will be almost fully functional, but maybe with small missing pieces to polish before a GA. It will have built-in Filecoin wallet, so if you give this to your parents, they don't have a Filecoin address, they don't even know how to create it, then it will be all handled by the station for them. We will have Saturn module, which will be connected to the mainnet, so it will be like real in production, handling production traffic, and there will be Filecoin earnings. Our current plan is to ship this in March next year. Cool. So that was kind of a slideware, and now how does it work under the hood for real? What is the technical architecture? We ended up with a kind of decoupled or modularized solution where we have a station process, which is an Electron application, providing the station interface, user experience. And then we are thinking about supporting multiple modules. Each module is a long-living process managed by station. And yeah. So again, Station is a lightweight Electron-based application. It has basically 3 jobs. One is to integrate into the OS trace, so it's just running on your computer without being too intrusive. It orchestrates the module. Right now, it means we will start and stop the module process. In the future, we might do auto upgrades of modules, maybe discovery, kind of app store, we'll see. And it renders a web-based UI in the Electron window so that you can have a nice dashboard. And then, this is an example how it looks like. It's probably better to download it from the website and see it for yourself. It's too small, sorry. And what is a module? This is a more interesting part or it might be more interesting to you. At the moment, a module is basically a long-running service which can be written in any language. For Saturn, we will just grab the Go binary of the Saturn L2 node and run it as part of the Station. We think we can keep using this approach for the next 2 to 3 modules to learn more about the whole requirements, what modules need from the Station. A module should consume smallish amount of computer resources so that people don't get annoyed by running Station, and it should pay rewards in Filecoin, which is quite tricky. And, if you want to build a module yourself, what is important to know that the module is configured by Station using environment variables. This is the old school 12-factor app design pattern, and it seems to work well for us as well. And the communication between the Station and each of the module is through std out. This allows us to capture all messages from the module, even if the module crashes or something, and we are not able to connect to the HTTP interface quickly enough. And then there is also a JSON over HTTP interface, which allows us to get more statistics, more data, maybe control behavior of the module in the future. And what is very important, right now, we are supporting only trusted modules. It means we trust people building modules that they are not going to mine Bitcoin or steal your secrets, because we don't have a fully isolated and sandbox runtime yet. And that's, you might be asking why, like why are we using Electron for all the other options there? And the reason is we want to ship and iterate quickly. I'm a Node.js guy. My colleague, Julian, who is working on the Station, is a Node.js guy as well. And if we had to learn Rust to write all of this on Tauri, then we would move much slower. And also because the main Station application is very lightweight, most of the heavy lifting is done by modules, then we feel it's a good trade-off, and we can always replace it with something better once we better understand the platform and if we actually find that people use it. Because if nobody uses it, then who cares if it's Electron or Tauri? And then the next big task in front of us, besides going public, is to find a way how to handle the sandboxing and resource limiting, which I mentioned at the beginning of my talk. So we would like to build a custom runtime, maybe similar to FVM, maybe closer to IPVM, which will allows module authors to run their code in an isolated environment, so we don't need to trust them to behave well. We can enforce it. And we also want to enforce limits on resource consumption, like network access or CPU usage. And the idea is we actually cannot use virtualization, so no VMs, no containers, because many consumer computers don't support virtualization. For example, Windows Home doesn't support Hyper-V, so there is no way how to run Docker on Windows Home computers. And fortunately, recently there was quite a lot of breakthrough done in in the isolate-based architecture. So if you think about Cloudflare Workers, Dino Deploy, but also like your V8, your Chromium browser, all of these systems are using isolation, where you have a JavaScript runtime or WebAssembly runtime, which provides isolation from the host machine, and it's secure enough. So we are thinking about leveraging the same approach. And the idea is the user will supply the hardware and operating system, on top of which we can install Station. And Station will have 2 parts. One part is the runtime, which allows modules to execute their code. It will be sandbox. We will limit the resources. And we can provide them platform APIs. Maybe it will be like POSIX, Unix APIs to work with files and network. Maybe we can go even higher level and give them, to put it, Web3 specific APIs like fetch me this CID, publish this file to Filecoin storage providers. There are many options which we need to explore. And on top of this, people will be able to build station modules and leverage all of this goodness of station runtime so that their job is much simpler. They can build a module in an easier way. And then there is even more things to research and think about, because the part I described so far is more about how can you run untrusted code on stations. But then another important part is how can we actually pay people for running that untrusted code, and that involves things like proof of job getting done, it involves billing, and then we also need to figure out how are we going to schedule jobs. And we are not sure yet whether this is something that should be part of the platform, of the station runtime, or whether this is so specific to each module that it needs to be implemented as part of the module. So more things to research. And I'm getting to the end of my talk. I would like you to give us, to let us know what you think about the station. You can download it from that QR code. I hope it works in this resolution. Or if you like any of the technical challenges I described, and if you have an idea how we can solve them, then please come and talk to us. We would be super happy to learn more. Or if you also have ideas how or what kind of modules you can or we can build and run on station, how we can leverage station to do distributed computing, caching, anything else, then let us know, and maybe we can even work together and build a module for station. You can join us or join our discussions in Filecoin-station channel in the Filecoin Slack. You can follow us on Twitter, Filecoin Station. And that's it, thank you. And you can follow myself at Bajtoš as well. And download the station, right? Give it a try.
So I think that, I mean, this is amazing. I think that one of the things that's sort of interesting comparing this, you sort of compared it to sort of Ethereum nodes and things like this. And one of the areas that I guess this falls partly into the legal side and partly into kind of like how do we encourage people to adopt this on a mass scale. One of the things we've seen in that space is, you know, people love downloading tools that make money for them, especially when they can download it onto other people's machines, right? So are you thinking about some sort of central control and reporting mechanism so that if somebody, say, decides to roll this out across a company that they're either the sysadmin or not, that you will be able to centrally control that? And does that mean that you are thinking about how to make a connection between the identity of the person who's receiving the Filecoin and the machines they operate on, and all of the questions that KYC and things like that raise? Thank you.
That's a great question. I think we haven't been thinking about that yet, but we definitely should. And then maybe I can ask you a counter question. If I'm running station on my employer's computer, should it be me earning the Filecoin, or should the employer be paid for it? So I think it's definitely something we need to look into. Yeah. But I think in theory, the idea or the design of station should allow for this, because station can decide which modules it will install and run. So maybe we can have a special profile for station. If it's running inside of enterprise, then the enterprise profile can specify you can run only this subset of modules, and then donate the earnings to your employer. Thank you very much.
Say I wanted to build a distributed health check system across all the stations, and some nodes will report, hey, this is down, and others, it's up. Is the consensus mechanism up to the module creator, or will you provide it as a station?
Right now, it's up to the module to provide a consensus mechanism. And I think our idea is to build first few modules in a way that the module is responsible for everything. And then we, as station authors, can look into these individual modules and look for opportunities to extract some of that difficult parts into station so that other modules can build on top of it. But we don't know yet what kind of consensus mechanisms will make sense, or maybe what kind of proofs modules will need, so we are waiting to learn more about the problem space.
Great, thank you.